Now that we have basically covered all the parts of the program, let's try to assemble this program and check out the result. As usual, we open a command line, and then we use the FASEM command to assemble the program. Here I wrote FASEM oneconsole.asem. I press the return key, and now I take a look at the output. As usual, we have the name of the assembler, then the version, and the amount of memory used by the assembler. This is the not very important part of the output. Next, we have some more specific output. It says that there was an error during the assembly process. The error says file not found, which refers to the file win32a.inc. We also get a hint about where to find the problem. It says that inside the file oneconsole.asem, in line 6, we can see this line, include win32a.inc, and this is where we get this assembly error. I want to emphasize that this error is related to the assembly process and not to running the program. We don't have a program yet that we can run. We don't have yet an executable file. This is just the part where we try to create the executable file from the source file. And we haven't finished this part yet. That is because we have this error. Let's try to resolve it. I think that this is pretty exciting. This is maybe the first error that you have with an assembler. It seems like FASEM cannot find this file, win32a.inc. And maybe if you think about it, it is pretty reasonable that this file cannot be found. How can FASEM know where this file is? We have to tell FASEM how to find this file. The way to do it is to add an environment variable called include. And this is what we are going to do right now. We are going to add the path of win32a.inc to an environment variable called include, so that whenever FASEM looks for files, we will begin by looking inside this folder, which is going to be pretty useful because there are other many include files inside this folder. To add an environment variable, we begin by pressing the Start key and then right-click on my computer. Finally, we choose Properties. In this window, we choose Advanced System Settings, and then we choose Environment Variables in the Advanced tab. In this window, we can see a list of the environment variables on the system. We can see that we don't have any include environment variable at this point, so we are going to add it ourselves. We click New, and then write down variable name include. Now we have to supply the value, which is the path of the folder which contains win32a.inc. In my case, it is inside D, Programs, FASEMW, Include. In your case, it might be something else. So check wherever you installed FASM, you have to follow it by the include folder. Now I copy the path and paste it here. Finally, I delete the last character, which is this. Now I can press OK, then another OK, and finally another one. And I can close this window. At this point, you might just try to assemble it again, and you will see that you still get this error. The reason for this is that you haven't closed the command line. So we are going to close the command line and open it again. Environment variables do not refresh if you do not close the command line. So you have to close it. I open the new command line and I try to assemble the program again. This time it works smoothly. As usual, we have the first general line of output, and the next one is now a bit more interesting. It says 3 passes, the time that it took to assemble this file, which is 0.1 seconds, and the amount of bytes, which is the size of the output. And this time the output is a bit larger. Let's take a look at what we got. We have this file, oneconsole.exe. As you can see, this file is much bigger, for example, than bear.bin, which was only 4 bytes. This is a huge difference. You might be wondering, what are all those 1,500 bytes? I didn't put any 1,500 bytes inside my program. Those bytes are the necessary metadata to be able to create a portable executable, or maybe in simpler words, an exe file. I'm going to begin by opening this file in a hex editor. Usually you will just run the program, but at this point I think that you are really interested about what is inside this file. I take this file and drag it into Hex Workshop. And this is the result that I get. This is what I see inside Hex Workshop. The first thing to notice probably is that this time the file is larger. It contains more data. It seems like most of the data is just zeros, which might be a bit surprising. Maybe the first thing that I would try to do is to find my code inside all of this mess. I remind you that the code that I wrote, which I originally wanted to run, is this piece of code. IncEAX, IncEAX, DecEAX, IncEAX. How can I find it inside this file? A good idea might be to use bear.bin. Let's open it again inside Hex Workshop. This is what we got from bear.bin. This is ink, ink, deck, and ink. Maybe we can just search for those 4 bytes inside console.exe. Remember those 4 bytes, 40, 40, 48, 40. We are going to search for those 4 bytes now. Oh, and we found those 4 bytes here. So those 4 bytes, 40, 40, 48, 40, correspond to those 4 instructions. Ink EAX, Ink EAX, Deck EAX, Ink EAX. You can probably guess by now that the rest of the bytes that we see here, following those 4 known bytes, are probably the bytes of the instructions push 0 and then call exit process. I want to discuss, maybe a bit generally, the structure of this file. We are not going to do this every time because all the files in Windows, all the portable executable files in Windows look pretty much the same. But I think that at least once it would be a good idea to try to understand what is inside this file. I do recommend that from time to time, if you add a section in your code or try to do something interesting, open the resulting file with Hex Workshop or with other Hex editor and try to understand what you see. Try to understand the difference between what was before and what you have now. Let's begin with analyzing this file. The first part is some kind of a header. It is some kind of beginning which is mostly the same in every portable executable file. We always have those 2 capital letter MZ, which are 4D, 5A. And almost inside every portable executable, we are going to have this strange line. This program cannot be run in DOS mode. And if you were wondering, this part is actually a very small DOS program written in assembly that prints this line. This is here for compatibility reasons, but I think that after some time in the Windows world, this kind of sentence will make you feel like home. Every time I see this sentence, I smile to myself, but only a bit. Let's see what we have next. We have all this kind of data scattered here, and we cannot say much about this data at this point, because it is hard to tell. But then we have some familiar things. We have here the word text, which actually begins with a point. I know this because I know that 2E means a point. And we also have iData. Basically, this part of the portable executable is some kind of a table. You can think about it as a table of contents for the file. It says which sections are going to show up inside this file and where can they be found. If you look really closely, and you can do it yourself later, you can find out that those numbers here correspond to the size of the text section and to its location inside the file. And the same goes for the iData section. Those numbers here correspond to where this section can be found inside this file and also correspond to the size of the section and some of its properties. For example, properties like code, readable and executable, and so on, could be found here and coded as numbers. After we have this table of contents for the sections, we have the sections themselves. An interesting thing to note about the sections is that they always begin with a very nice offset inside the file. For example, here we know that the text section begins, and we can see that it begins from a very nice address or location. It begins from offset 200 inside the file, which means that this is byte number 200. Of course that this 200 is in base 16. Let's move on. You can probably guess that this is the iData section. That is because we have here the strings kernel32.dll, which corresponds to this kernel32.dll. We also have exit process. In between we have those strange numbers that at this point we don't really know what they mean. Also note that this section begins at the nice location 400 inside the file. 400 in base 16. You can probably guess that all those zeros that we have here in between are just here to make sure that the sections begin at some very nice addresses. To make sure that the location of every section begins at a place which is divisible, for example, by 200 in base 16. And basically this is everything inside this file. There is not much to it. If you ever want to learn more about this subject or about the contents of an executable file, you should research the subject of the portable executable. You will be able to find much information about this subject. After we've looked at the contents of this file, let's try to actually run it. This is what usual people do with executable files. So we close Hex Workshop and we are going to try to run this file. The first thing that we can try to do is to click. As you can see, the program begins for a moment and then it ends, which is very unfortunate. I cannot see anything. A good solution would be to run this program inside the console. In order to do just that, I open a new console and then I just type in the name of the program, 1console.exe. I press the return key and now I got the program running, and then immediately it finished. I know that the program is finished because I can write things again. This is probably a bit disappointing because we wrote a program, we added all those things, and now that we run it, nothing very interesting happened. But this is kind of expected. As you can see inside the code of our program, it is only supposed to increase some register and sometimes also decrease the register, and then exit the process, which means that we don't have any meaningful input or output in this program. Basically, I'm not even sure that we can call this result, this executable file, a program, because it does not have input or output. We can just imagine that this program increases and decreases EAX, but we have no indication that this is what actually happened. We can just imagine it. By the way, this is probably what happens here. Probably the program increases EAX twice, then decreases it, and then increases it again, and then exits. And it happens so fast that we cannot see anything. But don't worry, soon we are going to write a program that is going to have both input and output. A program that we will be able to communicate with.